So today we're going to start on 3-1, and I'm going to do notes a little bit different. I have the sheet that you have right here, and that's what we're filling in. We're just going to fill it in together. Remember, you need to put these in your notebooks. Okay, so your section is topic 3, section 1, reflections. So a rigid, oh, I bet I don't have a pen. Motion is a transformation that preserves. What does preserve mean?
To
Keep. It keeps. So that's what this is. Keeps. Just so we remember what preserves means. Keeps length. And angle measure. Okay? So a rigid motion is a transformation that preserves or keeps length and angle measure. So, is each transformation a rigid motion?
No.
Okay, A, is that? Pre-image means what? What does pre-image mean?
Like the before.
Right, the before and the after. Okay, so is this before and after? Does it preserve it?
No.
Oh no.
If you flipped it and
Like if I reflected it and twisted it, then it'd be yes, right? But it didn't change the length of the sides and it didn't change the degree of the angles, did it? So this one is yes. Okay? What about this one?
No.
Why?
You just
because it
enhanced
changed
it.
the length and the angle.
We dilated it, was what that calls that. We made it bigger, and that is a no, because the angles are still the same, but the
Right.
lengths of the sides are different.
A dilation is an enhancement.
Actually,
Dilation is an expansion.
what if it just looks farther away, but really it's
Yeah, but in this one it's,
Okay, that just doesn't make sense because I thought a dilation was like.
no, when you dilate your eyes, you open them up. When you dilate something, you open it.
I thought dilated pupils meant your pupils are smaller.
No. Dilated
No,
means
it's
they're
like
bigger.
when your pupils like take up like
What do you call when your
95%
pupils are
of your
smaller?
eye.
No, you're talking about it. You don't talk
Undilated.
and dilated.
What?
I don't know.
swear that-
Dilation is when they get larger. A reflection is a transformation that reflects each point of the pre-image, and again, what's a pre-image?
the before.
The before, across Juan's standing at home asking me, what was that?
Write his name.
I think he can hear us.
I don't think he can.
Well, he can in the recording, but he's at home going, what is that?
Well, no, it's not live right now, so we would probably
Oh.
later on.
Okay. I get it.
Unless you're
We
recording
should have
this live.
FaceTimed him.
No.
Geez, Juan,
Why
you're
not?
skipping
Do
school.
you not like Juan that much?
No.
She's
It's
lying.
not that bad.
She has
Okay.
the same.
Especially
Across
when Coach Tyson
a line,
did the split.
okay, gentlemen, focus, of reflection. Okay, so it reflects across a line of reflection. We use the word reflection a lot. Okay, we used it a lot, but that's what it does. The line of reflection can be the x-axis, the y-axis. It can be just some random x or y line. Okay, reflection has two properties. If point A is on the line, on line M, here's our picture, okay? This is our pre-image, the black. And the red, I think the screen distorts the pictures because that's exactly the same. It looks like it's not, and it's exactly the same. It reflects across the line M. See how point A is on line M? So is it going to change? No. So if point A is on line M, the point is its image and its image are the same. And so that means A equals A prime. And A prime in here, prime means changed. So A is the initial point and the A prime is the changed point. It would be the same. If point B is not on the line M, then on line M, line N is a perpendicular bisector. How about I spell it right? I forgot an E.
Come on, you're making me erase it more.
Well,
And I don't care how it's spelled. It all means the same thing.
bisector of, okay, so let's look at this. Let's see, point B, right? Point B, point B. Perpendicular means they meet at a right angle. Bisect means exactly in half, yes. Add the line B, B prime. And it's not a line, it's a segment. I shouldn't have said line, should I? Am I good? Your stuff on there. Okay, reflections are written. So if we have triangle A, B, C, that's how we would write it, correct? Its reflection, oh, no, you're gonna erase again, because I forgot something in front of it. I wanna write how the book does. To show that we're doing a reflection, you say R, and it's a little m, and what that means is reflect across line M, okay? So if it was like line x equals 2, you'd have a 2 there. Does that make sense? So reflect across line M, triangle A, B, C. And so what you now have is triangle no longer ABC, but A prime, B prime, C prime. Does that make sense? Because our new points would all just have a prime on them since they were the reflection of the original. Okay, so a reflection is a what motion? What did we learn about? What was your first thing you had on there?
Radiant motion.
It's a rigid motion. Why?
Because it keeps or preserves.
Mine's A1.
It's a rigid motion because so the length, yes, and what?
Angle measure.
Angle measure. Are preserved. What's preserved mean?
Kept the same.
Kept the same, or I have the same. You can put whatever. Okay? So a reflection is a rigid transformation. It's not going to change anything, is it? Even though the screen makes it look the way I have the things on the screen makes it look like it is, it's not. Make sense? I think you guys have dealt with some reflections before in your math career, haven't you?
Yeah, algebra.
Yeah, you should have been. Gosh darn it.
In the middle school of Beatrice, we actually had a geometry class.
Yeah, you,
I don't think you did.
You guys scroll along.
yes, you did. They had a quarter, wasn't it just a quarter class?
Yeah.
Okay, so we have some examples here. The quadrilateral FGHJ has coordinates of 0, 3, 2, 4, 2, 4, and negative 2, 0. Graph and label FGHJ, and then reflect it. So you need to.
How'd you put the dot out there when it's 0, 3?
Oh, I don't know. Oh, yeah. It's not, yeah. It should not have been there. I was like, what's wrong with my picture?
So we connect the dot.
I like the dot.
Wait. Why is it so funky?
I don't like
Well, I think it's so funky again because your paper should be, is it square on your paper? Like,
No.
your picture, your coordinate isn't, no, but your coordinate plane is square. Mine is not. See how mine's stretched because it's on the screen? Yours is at least a square.
No, I'm talking about why is it
Because it's just a quadrilateral, and they didn't want it to be a rectangle specifically or anything.
a simple
Okay,
square
so-
circle.
This is what? F,
You can't do
G, H, J?
it.
Okay, so I need to reflect it across the x-axis. So that means I need to take this thing and move it what? I need to flip it over, don't I?
Yeah.
So what do I do to it to flip it over?
Well, you could take the H and you could go, since the H
Well,
is
first of all, J would stay the same.
no. J
Yes, J would stay the
Or
same
yeah.
because it's on the x-axis, right?
Okay, well, since you have that there, then H would go from 4, 2 to negative 4, negative 2.
Negative 4, negative 2 would be
Or
over
negative 4, 2. Or negative, or 4, negative 2, sorry.
4, negative 2, because what's not, the x's aren't changing, what's going to change?
Why?
The y's. So this h is going to be 4, negative 2. So this is going to be h prime, right? And j prime and j are going to be the same because they fall on the same line, don't they? And what's 0, 3 going to become? 0, negative 3. So that's going to be f prime.
And G is gonna be negative 2, negative 4.
2, negative 4. And that's going to be what? G prime?
I can't tell what I'm doing on
horrible tracing on my hair. Is that correct? Okay. So I didn't change my angles. I didn't change the length of my sides. Did I? What is the general rule here?
Well, if it's on the x-axis, it stays the same.
Yep, because that was the line, right?
You just flip the one.
Okay. So we just made the y's what?
Negative.
Negative. Okay. If they were negative, we would have made them what? Positive. So I think it's on your next page, actually. Oh, that's okay. We'll just do the next example. Okay, it says graph it again. I'm going to put it here. So graph the same one, the same quadrilateral again.
Like the first one we did?
Uh-huh. Okay. Now it says reflected across the y-axis.
So anything on the y-axis stays the same.
Okay, so F is going to be the same as what? F prime, right?
Yeah.
So it doesn't move. What's going to happen with G?
It's gonna be
It's not going to be 2, 4 anymore. It's going to be what?
2, 4.
Negative 2, 4.
How are you flipping it?
Yep, we're reflecting it across the y-axis.
So then H would be negative 4.
Negative 4, 2 is going to be H, or H prime, right?
J would be a positive 2.
And J is going to be positive 2, 0, J prime.
Yeah.
So I now have, and this was the same, right?
Looks even more funky.
It does.
It looks worse on paper.
That's worse on paper.
It looks even worse if you can barely make that look without straight lines. I'm not very good at that type of thing.
Well, hopefully you get better.
I don't think
Questions,
it's gonna
guys?
happen.
She's saying you're bad.
Okay, so we're gonna come back to this one real quick, but I'm gonna go here to start before we go back to the triad. Your next page. So the concept, when reflecting points across the x and y axis, when any point P, x, y, on a coordinate plane is reflected across the x axis, its image is P prime. And what did we do to it, guys? What did we do when we did the x-axis? What did we do to the coordinate? But what did we do? Like, what did we physically?
The line.
We changed the y. We made it negative, right? And if it was negative, it became positive. So it's x, comma, negative y. Meaning y is the opposite sign of the starting point. You guys always like that word opposite, so I'll let you say the opposite sign, okay? So if it's negative, it becomes positive. If it's positive, it becomes negative. When point P, x, y, on the coordinate plane is reflected across the y-axis, the image is P prime what? Negative x, comma y. X is made the what? Opposite sign of the starting point. So when we reflect it over the x-axis, I do the negative y's. When I reflect it over the y-axis, I do the negative x, because that's what's happening, right? You go to the negative side of the coordinate plane.
Now this kind of algebra makes sense.
You deal with reflections a lot.
That would make sense.
Okay, so now let's go up to our examples. You guys good? All good?
It's not using voodoo magic to get answers.
Okay. Now, I'm going to tell you guys, I just told you what you could do with your coordinates, right? So if you want to list them out before you plot them, it would be totally fine as well. I don't care. Okay, so we have the triangle. A is negative 5, 6. B is 1, negative 2. C is negative 3, negative 4. What are the coordinates of the vertices of A, B, C for each reflection? So, x-axis, what do I do when it's the x-axis?
You change it up.
Change the y, right?
Yeah.
So my coordinates are going to be what?
Negative 5, negative 5, negative 6.
Negative 5, negative 6. For B prime, what are my coordinates going to be?
1, 2.
1, 2. Opposite sign, correct?
Yeah, then
And
negative 3, 4.
C prime is going to be
Negative 3, 4.
negative 3, 4. So graph that.
Oh,
And if you want to put both of them on there, you can. Did anybody graph?
Yeah.
Okay, we're working on factoring in today and starting. Are you going to be back on?
What?
You'll be back tomorrow?
I might.
Okay. But check your calendar for that. We're
Alright.
doing the Khan Academy again though.
Are you gonna use Khan Academy?
Okay, so did anybody graph the original
I did.
also? Does it reflect?
Sure.
Did we do it right? So
Oh, that's what we're doing. Just figured it out.
Idiot.
be nice.
Sorry.
Yeah, you know.
Stupid. This minute, Tyson threw something at me.
Okay, none of those stayed the same, but did I just reflect those two things?
Yes.
Yeah.
You did a rotation.
No.
It technically, it reflected. It didn't rotate.
It looks like you could just take it and rotate it.
No, because if I rotated it, this corner would be
Oh.
here, not there.
I was thinking, I've heard, isn't it a rotation? You keep one
You-
point the same. and
Yeah,
rotate it?
rotation.
Okay. I
Yeah.
was thinking like rotating the whole image.
No.
Instead of keeping one point the same.
Okay, so over the y-axis, what are my coordinates going to be over the y-axis?
5, 6, negative 1, negative 2, and.
So
3,
A
negative
prime,
1.
I'm making the negatives on the x's.
So 5.
So
6.
5, 6. B prime is negative 1, negative 2. I don't know why I'm putting equal signs in there. And it's 3, negative 4. So 5, 6. -1, -2. And 3, 4.
No.
3, -4.
Yeah.
3, 4 did not work. That was almost a straight line.
I was confused. I was like,
I was 2 for a second. I'm like, wait a second. Now, what if I wanted it reflected over the x and y axis? What would I do to my
you have
point?
to change both of them.
I would have to change both of them. Now, I think on your homework it says just write the points.
Thank goodness.
Pretty sure.
I wouldn't have drawn anything.
Or just if he wants to.
Once like Connor, you really want to draw
No.
stuff.
Okay, good.
No.
No?
Huh?
It's on your
Maybe
paper.
you've seen both clovers draw. Get Brad and get Brad.
Both
Which
of
one's
those?
Nicole?
They both have clover. The whole clover family has it.
Okay, Connor.
Yeah.
You're being recorded, and the whole world doesn't need to know that.
Yeah, Connor. Disappointed in you.
Okay, so we talked about it being the opposite. Algebra review. Algebra review.
As long as it's not the voodoo magic.
Okay, point slope form. Equate the point slope form of a line. It is y minus y sub 1 equals m times x minus x sub 1. Okay, this is an algebra review. Now, what is m?
Measure.
No,
What's
what is m?
line?
Slope. M is slope.
Oh.
Yes? And how do I find slope?
Y1 plus Y2 plus
y2 minus
Y1
Y1
over
over x2
minus
minus x1. Now, last topic we did parallel and perpendicular lines, and I said it's not going to go away. Guess what? It's not going to go away. We're going to keep doing it so you guys get it. And
Oh, if I get it.
x1, y1 is a point on the line. So this is my favorite form to use. It really is. Because I plug in my slope, I plug in my 1 point, and then I add my slope, add my y over, distribute my slope, and combine like terms. And guess what form I have it in? Slope-intercept form, which is what? Y equals
mx plus b or something like that.
mx plus b.
Huh.
Now, when we had to do perpendicular and parallel, we had to plug in the point and the slope and then solve for b and then plug it back in, didn't we? If we use point slope form, we don't have to plug it back in. All we have to do is solve for it.
I'm gonna take a nap in this class tomorrow.
She said she would.
So, we are going to be continually reviewing those algebra things, guys, so we can use them to our advantage.
Sometimes advantages aren't good
What? How does that make sense?
And if you want to highlight that M is your slope and B is your... Guys, what is a y-intercept? When I say that, what does that mean?
It means that's a y-intercept.
Where it crosses the y-axis, yes? Where it touches.
You got the pick. Pick 6. Intercept.
Or you never get it.
Garbage.
That looks horrific.
Okay, so we need to describe the reflection.
It reflected.
Moved and reflected.
It reflected.
It's a
reflected.
It reflected.
Reflected
It's
or
just,
not?
okay, it's, the screen is not nice and pretty. It reflected.
It reflected.
What did it reflect across? It's on my desk.
Oh no.
Okay.
Yeah.
It didn't reflect across the X or Y axis, did it?
Did the, is
Evan.
the one T line?
Evan, come here.
No.
Let me give one to you. I have to give him something for Miss Goonikaki for my sister. They're in here somewhere. Come here.
Okay, but Bladen, I'm trying to record and other people are trying to learn.
Okay.
So you need to be quiet about this. Okay, so it's reflecting across this T line, isn't it? You see that?
I guess so.
So let's look at what are all the things that are happening. What do you notice about L? Is it the same distance on both?
Yeah.
Yeah. Okay. What's the coordinate of L?
1, 3.
1, 3. What is the coordinate of K?
Negative 3, 5. Yeah.
What is the M?
Negative 5, 1. Wait.
Okay.
The reflections, you just switched the
Okay. Just what's L prime?
3, 3, 1. And then K is 5, negative 3. And then M is 1, negative 5.
But I need to come up with some algebra that tells me this. Okay. Now I can first figure out, is this a reflection, by making sure that they're same distance apart. Yes. How do I find the distance between two things?
The distance formula.
I can't count it.
The distance formula.
The distance formula. Okay. I also can look and see, I can count my slope, make sure it's the same going here in the same number of times. So there's different ways. If it's straight across, I just count them, right? If it's horizontal or vertical, I could just count them.
You count them like that?
Well,
They're straight.
right, because I have the grid and all that. But if I didn't have the grid, I couldn't count them. Okay, but I need a rule, so I need to figure out and make sure that all these work. I need a rule for this, so I need an equation. So I'm going to use y minus y1 equals m x minus x1. I think that's what they want me to do here. Maybe not. Let me check. I don't want to make it harder than it is. Do you want me to make it harder than it is?
No.
No. Yes?
No.
It would be fun, wouldn't it, Kaisen?
No.
I would not.
Okay, I need to use that, but I'm not doing. They want this equation. Right there. Okay, now the two rules I gave you on a reflection. The first one was if a point was on the line when you reflected, it stayed it, right? What was the next one I gave you? The first sheet. What was the second thing about, was it on the first sheet? Yes. If a point was on a line, it stays the same. What was the second one? If the point's not on the line is the what? Perpendicular bisector. Yes? So perpendicular means it meets at a what angle? Right angle. Bisector means it's in half. Yes? Okay, so I need to find the midpoint. I need to have 2 points on this line here, don't I? And they're nice. I have a picture, but am I always going to have a picture? Nope. So I need to review my midpoint. How do I find midpoint? Mid means middle, right? I average them. Remember that? Okay, so the midpoint, let's do K and K. K and K prime. I forgot my primes, didn't I? Okay, so I'm gonna add my x's. So I'd have 5 minus 3 over 2 and negative 3 plus 5 over 2. And that's a point, yes? So 5 minus 3 is what? 2. 2 over 2 is 1. Negative 5 plus 3 is 2 over 2, which is 1. So on the line between k and k prime, I should meet at 1, 1, do I? I do. Okay, so now let's go here. So then I have negative 5 plus 1 over 2, comma 1 minus 5 over 2. And it's a minus because it's negative, right? Connor? Okay, so negative 5 plus 1 is divided by 2. Negative 2. And then 1 minus 5 is negative 4 again. Negative 2 again. Did negative 2, negative 2, is that where it intersects here? Yes? Now, if I have 2 points on a line, can I write the equation of that line? Yes. Because I can use the 2 points to find the slope, and then I can use my y minus y right there. So I need to find my slope. So the 2 points I'm using are the 2 points on line T. Because I want that equation. I want to know what I'm reflecting this line over. Make sense? Okay, so slope equals negative 2 minus 1 over negative 2 minus 1. Y's over x's, right? So negative 3 over negative 3, which is 1. Now you get to pick. Do you want to use 1, 1 or negative 2, negative 2? 1, 1 because they're positive. So we're going to plug them right into here. So y is just y equals, not equals, minus. And what's I'll put the point that we're going to use. We're going to use the point 1, 1, right? So here's our point, here's our slope. Okay, so y minus what? 1 equals, what's my slope? 1 times x is just x minus 1, because this is x, this is y, correct? Distribute the 1. So I have y minus 1 equals x minus 1. Now, how do I solve for y? Plus 1 here, plus 1 here, so the line is what? Y equals x. So our rule for this is R standing for what? Reflection. And then you put y equals x. So what did we have to find first? The midpoint. We found the midpoint because it's a perpendicular bisector, right? It's in the middle. So once I had 2 points, I could find the what? The slope. Once I had a slope, I just picked a point, I plugged it back in. So let's do it again. Hopefully I gave you guys enough room. I don't have to write it all out because it's there, right? So which 2 points do you want to use? So E and E prime. Okay. So E E prime, midpoint. So that's going to be 4 minus 6 over 6 minus 4. So negative 2 over 2, which is, what am I doing?
Wait, I'm really.
I'm not doing midpoint. I was doing some funky,
Yeah, that's why I get confused, isn't it?
yeah.
I was like.
I was doing it and then I was like mixing midpoint and slope, wasn't I? Okay, let's do it right. Okay, 4 minus 6 over 2. How about that?
Yeah,
And 6 minus 4 over 2. So 4 minus 6 is negative 2.
negative 2,
Over 1 is
negative 1.
negative 1. And 6 minus 4 is 2 over 2, which is 1. Desiree, what other point? C or D? D. Okay, so D prime, midpoint, is going to be 5 minus 12 over 2, and 12 minus 5 over 2. I almost did the same thing again. Okay, so 5 minus 12 is negative 7, right?
I don't know what direction.
We're going to have one. And then 12 minus 5 is 7. So we have 7 over 2. Do we want to do C and hopefully we don't get fractions? Okay. We may have to deal with them, but if I get a fraction, I have another option, don't I? Okay, so C prime. Okay, so I have 3 minus 8 over 2, and I have 8 minus 3 over 2. Guess what I'm going to have? A fraction. We might want to do the two fractions because they already have common denominators, right? It sounds weird, but we might want to just use the fractions. And I think I do. Because if I'm going to have to subtract fractions, I have to get common denominators, don't I?
Yeah.
And they already have them, so I wouldn't have to do anything with that, would I? So I found the midpoint, now I have to find the what?
That's so bad.
The slope. So m equals, we're going to use these two. So 7 over 2 minus 5 over 2. All over negative 7 over 2 minus the negative, so it'd be plus, right? 5 over 2.
Wait. Oh, wait, never mind.
Okay. So in the numerator, I get 2 over 2. And the denominator, I get negative 2 over 2. So what's the whole thing equal?
2 over 2. Bottom line.
Negative? Because the bottom one's negative and the top one's positive. So I have my slope. Okay, I have my slope, guys. The point that I'm going to use is not these two. What point am I going to use?
Negative 1, 1.
I'm going to use that point. So I'm going to do it real quick. So y minus 1 equals negative 1 times x minus a negative 1. So it's plus. Distribute my negative. So y minus 1 equals negative x minus 1. Add 1. Add 1. So just a second, please. Just a second. So I have y equals negative x. So the rule is r of y equals negative x.
Didn't even get us to